friends, this video on work, energy and power part 13 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos from part 1 to 12 before going ahead with part 13. Here we will see work done in a spring. We will consider scenarios one by one. So let us first consider the scenario where we say that the spring is stretched. So when the spring is stretched, in that case, X will be positive, that is the displacement will be positive. However, Fs, that is the spring force, will be negative. Correct? See, here I have purposely not included the diagram so that you can visualize the diagram on your own. However, you can always refer the previous slide to get a reference of the diagram. Spring when stretched means the spring is getting elongated. So in that case, X is positive, Fs is negative. So what would be the work done? We know work done is nothing but force into displacement. So work done in this case, because the force here is a variable force, which we discussed before. This force is variable force because it depends on displacement x. So this will be equal to Fs integration of Fs into dx from x initial to x final. Right? So this will be the work done. So this will be equal to, what is Fs? Fs is equal to minus k into x dx. And it will elongate from which point to which point? Let us say initially it was at 0. Initially the spring was at rest. So let us say that initially x was equal to 0. That is, initially the displacement was 0. And let us say that the maximum displacement is xm. So we can say minus k x square by 2 from 0 to xm. So we can say this is xm square divided by 2. So this will be the work done for stretching the spring from x is equal to 0 to x is equal to some value xm. Correct? What I would suggest you is, when you are doing this, you try to visualize the figure. Try to draw the diagram on your own and try to visualize the scenario on real time. Now let us look at the second scenario, that is when the spring is compressed. Now when the spring is compressed, in this case, x will be negative. Therefore, the spring force will be positive because spring force is always in the opposite direction of that of the displacement. So in this case, what will be the work done? Many times the work done in case of a spring is denoted by Ws. This S subscript is used for the spring. So the work done in this case will become Fs into dx. Again here x initial to x final. Now in this case, everything else will remain the same. It will be minus kx dx. What will be the initial? Here initial will be xm and final will be 0, because here the spring was already stretched and now we have compressed it. That means it was already stretched, means it was at the position x is equal to xm. Now from x is equal to xm, we are compressing it to x is equal to 0. In this case again we will get minus kx square by 2 xm 0. So we get kxm square divided by 2. So this would be the work done in this case. Now let us assume a scenario. So we considered both the cases, when the spring is stretched and when the spring is compressed. The funda remains the same to calculate the work done, just that you need to know from where to where. Now let us consider that we have a block which is moved from xi to xf. That means the initial position was xi and the final position is xf. So in this case, what would be the work done? It is very simple. Work done will be equal to integration Fs dx, where x from x initial to x final. So this will be equal to integration of minus kx dx, x initial to x final. So this will be equal to minus kx square by 2 x initial to x final. So this will be equal to minus k xf square by 2 plus k xi square by 2. So this would become the work done in moving the block from initial position xi to final position xf. So now I hope it is clear how do we calculate the work done in case of a spring. Okay, now let us go ahead and let us see let us conclude all the points which we studied about the spring force. Right. So the first thing we learnt about spring force is the work done by spring force in a cyclic process is equal to 0. What do you mean by a cyclic process? Cyclic process means the point from where it starts, it comes and ends at the same point. That means x initial is equal to x final. The initial position is equal to the final position. So what will be the work done in this case? Work done just now we found. Just if you look at the last example in the previous slide, you will see that the work done in moving an object from initial position xi to final position xf, that was given by this. And this was nothing but, it came out to be something like this, minus k xf square by 2 plus k xi square by 2. Now if I say that xf is equal to xi, then what will you get? You put xf is equal to xi. So this will become xi square by 2 plus k xi square by 2. So they both will cancel out and we get work done is equal to 0. The next is Fs is position dependent, that we already saw, because Fs, the value of the spring force as well as the direction of spring force, depends on the displacement. And what is displacement? Displacement is nothing but position. Next is spring force is a conservative force. What is a conservative force? Conservative force is a force in which work done in moving from one point to another point is independent of the path. In this case, you can see that the work done depends only on the initial point and the final point. It doesn't depend upon the path which is taken to reach the final point from the initial point, right? So what we see, Fs depends only on xi, xf, and it depends on xi, xf and not on the path. I'm sorry, it is not Fs. It is not Fs I'm talking about, it is Ws. The work done does not depend on the path. The work done depends only on the initial position and the final position. Therefore, the force associated with this work done is a conservative force. Right? So, any force which is associated with a work which does not depend upon the path between the initial and final point is called a conservative force. So the spring force is a conservative force, it is position dependent force and it is 0 in a cyclic process. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.